Welcome back, students. We are currently discussing problems on trigonometric ratios. Last two videos we have discussed a few patterns. In this video, we'll continue discussing a few more patterns. So we have completed the trigonometric ratios theory part, and presently we are discussing sample and board problems. So before we proceed further, a small heads up I need to give. See, I am giving lesser importance to textbook problems, but priority to past board problems. It doesn't mean that textbook problems are not important. It is important, and wherever I deem it is important, I will cover textbook problems as well, textbook exercise, whatever. Main purpose of me not considering it is there are hundreds of PDF files. You can check in Byju's or selfstudy.com. There are a lot of websites which have published you the answers for textbook problems. So I'm giving lesser priority to that for that one reason, because board problems are sometimes tricky for you to not difficult, but it needs more of application and understanding. So I'm dealing more with the board problems. Even the CBSE has recently released the sample papers for 2026. That also we will do chapter wise in the coming days. And by board problems, I will not be covering every board problem or every past board problem. I'll be picking up one sample, simple or complex, covering different models. That is more important. So to have a practice or hold up across all the samples, I request you to practice. So you need to have a question bank. The one on the left is what I'm using. If you're using the same thing, well and good, or otherwise have some question bank and practice similar problems so that you get a good hold of it. And as we read, as we teach, before I teach the answer, you can just pause the video and try the solution for yourself to see if you're able to make it or to compare what mistakes you do. Then you can see the solution, whatever I teach you. So now let us move to the problems of this video. So they have given sin theta is equal to a by b. What is the value of cos theta? So this is the problem, and there are four options. So the one high level solution is sin theta is equal to opposite side by hypotenuse, and cos theta is equal to adjacent side by hypotenuse. In both of the this thing, denominator is hypotenuse. Okay. So if b is the hypotenuse in sin theta, even cos theta should have b as the hypotenuse. And here it's a mistake. I have put as numerator. It should be denominator. Okay. The one option which has b in the hypotenuse is option C. Option. Oh, I'm not getting the pointer. It is option C. But this is not the way that you should solve it. But this is I'm giving as a high level pointer for you to quickly validate your answers. The solution is adjacent side is equal to, because you need adjacent side to calculate the cos theta, because cos theta is equal to adjacent side by hypotenuse. Adjacent side is equal to hypot square minus opposite side square, which is nothing but square root of b square minus a square. So cos theta value, which is root of b square minus a square by b, which is nothing but option C. So the second problem is they have given that D is the midpoint of BC. That is a key thing which you are supposed to apply during a solution, and they are asking you the value of cot y by cot x. Cot is nothing but adjacent side by opposite side. So that ratio you must be well aware. And options are, there are four options here. So let us go to the solution. Since cot y, so you are trying to figure out first cot y. Cot y is adjacent side by opposite side. Adjacent side, cot y is here, this y degree. The adjacent side is AC and opposite side is full BC here. Okay. So it becomes AC by BC. Next I am trying to figure out cot x. Similarly it is AC divided by DC, the small part. So now both have been updated. So now the midpoint D is at the midpoint of BC. So which means this D is dividing this line BC into two equal halves. This DC is equal to DB, which also means to say that it is twice DC. So now I'm going to apply that concept here. Cot y by cot x is equal to, this goes in numerator, AC BC goes to numerator, AC DC goes to denominator. And since I know BC is twice DC, I'm going to substitute that in the equation here. Upon simplifying, I get the answer as half, which was the second option. So going to the problem 3. you should be really lucky to get such problems. They are given you a sine, you have the opposite side and hypotenuse. For secant, you need the adjacent side. So adjacent side you'll be calculating by square root of hypot square minus opposite side, that is 16 minus 9 is equal to root 7. So secant A is equal to 4 by root 7. Then you have a problem 4. ABC is a right angle triangle at B. Note this point, at B it should have been 90 degrees and they have given you the length of AB and length of BC, and you are required to find out the value of sine A, cos C and cos A, sin C. When given something like this, first draw a diagram. Now it is right angle at B and the value of AB is 6 units and value of BC is 8 units is come up here. Okay, you need to find out the value of hypotenuse, that is a calculation. Hypotenuse is nothing but square root of square of adjacent side plus opposite side, which is equal to 64 plus 36 is square root of 100 is 10 units. This calculated value comes here. Now we have everything in the diagram. You are supposed to calculate the value of sin A cos C plus cos A sin C. So first individually I calculate each of the individual terms. Sin A is somewhere here. Opposite side is 8, hypotenuse is 10, 8 by 10. I simplify it to 3 by 5. Then sin C you should see here. Opposite side is 6. So 6 by 10. On simplification becomes, I think everything has gone wrong here. 1 minute. This should have been 4 by 5. This should have been 3 by 5. This should have been 3 by 5. Similarly, this should have been 4 by 5. I'm sorry about this mistake. Some copy paste error has gone wrong badly. Okay. So now similarly cos A. Cos A is adjacent side. Adjacent side is you have 6 by 10 and cos C is adjacent side 8 by 10. So having all the values and simplified, now we can multiply sin A into cos C. Sin A into cos C is 4 by 5 into 4 by 5, which is 16 by 5. Similarly, cos A into sin C, that is 3 by 5 into 3 by 5, that is 9 by 25. When you add both, the answer is 1. So now we'll go to the last problem of this video. PQR is a right angle triangle at Q. So note that you must have that right angle part at Q, and one of the length QR is given as 9 centimeter. You don't have the other two dimensions, or even one of the dimensions for you to use the hypotenuse or the Pythagoras theorem. But you have a hint or a relationship between PR and PQ. You have the relationship between this and this. What it says is the difference between both is 1 unit. So find the value of sin R plus cos R. So whether you have the solution or not, straight away put the Pythagoras theorem, PQ square, hypotenuse square, PR square, hypotenuse square is equal to PQ plus QR square. Okay. Then PQ I don't know, QR I know it is 9, so 81, and PQ what I am doing is, whatever they again, PR is equal to PQ is PR minus PQ is equal to 1. I am just shifting that portion and substituting the value of PR as PQ plus 1, and I am going to square it. Upon squaring, it becomes PQ square plus 2PQ plus 1 on one side and PQ square plus 81 on the other side. This both get cancelled, and solving for PQ, you will get the value of PQ as 40. Now that you have 40, you can find out straight away PR even without using the Pythagoras theorem. So you have the difference, you have the relationship between PQ and PR. Like PR is 1 times 1 unit more than PQ. So just add 1, so PR becomes 41. That is what I have put in the hypotenuse here. Now we have all the needed values. So you calculate sin R first. Sin R is opposite side by hypotenuse 40 by 41. Similarly, cos R is adjacent side 9 by 41. When you add both 40 by 41 plus 9 by 41, denominator is 41 and the answer is 49 plus 41. So in the next video, we will take up a new topic, that is the trigonometric ratio specific values like sin 30 degrees, sin 60, sin 45 and so on. Till then, bye. Thank you.